All right, welcome guys. Today we're going to talk about three different things, all using trig ratios. The first we're going to talk about is how we can estimate our two missing sides based on our 90-degree angle, our 40-degree angle, and our side. So the first thing I want to think about is my third angle. In this case, I've got 90 plus 40 is 130. Take that away from 180, and I want to know my third angle is 50 degrees. Okay, the reason I want to know that information is it tells me a little something about these sides. If you remember from previous units, we learned that across from the 90, the hypotenuse is your largest side. We also learned that across from the 40, because that's the smallest angle, that's going to be my smallest side. And across from the 50 is 50's in the middle of 40 and 90, or it's in between 40 and 90. So this side is going to be in between these two sides. So my second thing I want to think about is if I had a 45, 45, 90 triangle. If I knew what that side was, well, because my angles are the same, then my opposite sides would be the same. Okay, so the other reason I want to, or the reason I want to know that is because I want to compare the 45 angles to these two angles. Well, that's slightly below 45, that's slightly above. That tells me that these two sides are going to be close in length. But I know the 5 across from my 50 is going to be larger than this side. So I'm going to say this side is going to be somewhere close to, we'll just call it 3.8. And that's just a complete estimate. But I'm just trying to get the understanding that I know this side is smaller than this. Okay, for my hypotenuse, I know that it's got to be larger than this side because that's my medium side. But I also know from previous units that if I add these two together, it has to be larger than my hypotenuse. So this side cannot, it's got to be smaller than 8.8 because 5 plus 3.8 is 8.8. Okay, the other thing I kind of want to think about is if I were to take this and I were to keep this here and swing this side up, swing that side up, it's going to be about, that length right there is going to be about 5 if I started from there. Okay, that's just a pure estimate again. So now I'm kind of thinking, all right, if I broke this down into 5 units, 2, 3, 4, so 1, 2, 3, 4, 5, all pretty close. I can keep that kind of same pattern in my head. 6, 7, I would say that side is, I'm going to go 7.5 just as an estimate. It may be closer to 8. But just trying to get a basic idea of that side length. Now, I don't actually draw the dashed line. I don't actually break that up. That's just stuff I do in my head as I'm thinking about it. Okay? All we're doing is just estimating right now to see if these things are close. And you'll see in these next two examples why we do that. So here, we're given an angle, we're given our hypotenuse, we're looking for our adjacent side. So if we go back and think, SOHCAHTOA, okay, I have an angle. So the angles are the S, the C, and the A. So I have an angle, I'm going to mark it on all of them. I'm looking for adjacent. Okay, this doesn't have adjacent in it, so I'm going to mark it out. And I know hypotenuse. That doesn't have hypotenuse. That does. So I'm going to use cosine. So here I'm going to use the cosine of the angle given is equal to, cosine is equal to adjacent divided by hypotenuse. So adjacent divided by hypotenuse. And once I have that, I know that the cosine of an angle just gives me a ratio. And so this is just going to be a decimal point. So now I know that this side of the equals is going to be that same decimal point. And to find out what x is going to be, I'm just going to solve for x. I need to get 11 out of the denominator, so I'm going to multiply it by 11. So that would give me 11x divided by 11, which just turns into x, because your 11 in the numerator and 11 in the denominator will cancel. But I'm also going to have to divide this side by, or multiply this side by 11. And when I do that, in my calculator, I'm going to type in, depending on the type of calculator you have, 11 times the cosine of 62 tells me x is 5.16. Okay. Now the reason I estimated a minute ago, because if I come in and I say x is 5.16, I just want to make sure that that makes sense. So if x is 5.16, this side has to be at least 6, because 5.16 plus 6 would be larger than 11. So 6 is about the minimum that could be. Once again, all I'm trying to do is figure out if that makes sense. And to me, that makes sense. And if I were to swing this up here, now granted, these aren't drawn necessarily to scale, I would say that's probably about the halfway point. That seems reasonable that it's 5.16. All right, now my second example. I'm going to estimate first here just to see how good I am. This angle is 53. That means I'll have an angle of 37 here. These two are both kind of close to 45. That's 8 above, that's 8 below. This is bigger than that. So I know this has to be larger than 5. Just estimating, I would say, this may be 6.2. And that's just a blind estimate. That may be, I may be farther off than I think. All right, so I'm gonna do the same thing. SOHCAHTOA. I'm given an angle. And once again, I just do this stuff in my head, but it may help to write it out the first couple times. I have the adjacent, and I'm looking for the opposite. So I'm going to use tangent in this one. So the tangent of my angle, 53 degrees, is going to be equal to the opposite divided by the hypotenuse. So the opposite divided by the adjacent. Okay, same thing on this. Multiply both sides by 5, and they're going to cancel. 5 times the tangent of 53 tells me that's 6.6. Okay, so I was pretty close in my estimate. And I like to do that ahead of time real quick so I can see how close I am and if my answer makes sense. So let's look at one other part. I'm just gonna flip this angle real quick. All right, let's say this angle were 40. Let's say this is just 40. And this time I'm given my adjacent of 8. And I'm going to look for my opposite. So we're going to use the same one. We're going to use tangent of 40 is equal to the opposite let me flip those. Tangent of 40 is equal to the opposite divided by the adjacent. Okay, this time we've got x in the denominator. So I'm going to show you the long step to do this, then kind of allow you to see the shortcut. If I multiply this side by x, I have to multiply this side by x. Those x's cancel out, leaving me x times the tangent of 40 equals 8. And then I can divide by the tangent of 40 and those will cancel out. Leave me x is equal to 8 divided by the tangent of 40. So my calculator, I'm going to type that in. Telling me x is 9.5. Okay. So I always do 1 or 2 in this method, and then I realize when I get to this point, like I said, I'll always like to do 1 or 2 first to make sure that I'm doing it right. I realized that I could just take the tangent and put it there, and take my denominator and put it up here, and it gets to that point.